Today's lesson is about prime and composite numbers. At the end of today's lesson, you should be able to identify prime and composite numbers and write the prime factorization of a number. So some numbers are prime, while other numbers are composite. What exactly does that mean? When we learned about factors, we learned that every single number has factors, and whether a number is prime or composite depends on how many factors it has. So let's take a look at the number 3. When we think about what can we multiply together to get the number 3, there is only one multiplication expression that will get us 3, 1 times 3, which means the factors of 3 are 1 and 3. That means this number is prime because it has exactly 2 factors. Let's take a look at another number. How about the number 6? 6 has more than 2 factors, so we can multiply 1 times 6 together. We could also multiply 2 times 3, which means its list of factors is more than 2. 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor, which means this number is composite. 6 is a composite number because it has more than 2 factors. Make sure you take note of these definitions. A prime number is a number that has exactly 2 factors, and a composite number is a number that has more than 2 factors. All right, hopefully that was review for you. Now let's talk about prime factorization. When we want to break a number down to only prime numbers, we can use prime factorization. So let's take a look at the number 12. I'm going to use what's called a factor tree to determine what are just the prime numbers that I can multiply together to get 12. So 2 times 6 is one way to get 12. 2 is actually a prime number. If you think about it, 1 times 2 is the only way to get 2. It has exactly 2 factors. But I can break 6 down again. Let's see, 6 is the same as 2 times 3. 2 is a prime number, and 3 is a prime number. The prime factorization of 12 is 2 times 2 times 3. Now we can simplify this expression a little bit, and I can put these together. So instead of saying 2 times 2, I'm going to say 2 to the second power times 3. This is equivalent to 12, and this is the prime factorization of 12. Let's look at another example. All right, this time, how about the number, I don't know, let's do a bigger number. How about 50? So what are ways that we can get 50? Well, we could do, I know it's even, so 2 is always a factor. 2 times 25. 2 is prime, but I can break 25 down. 25 is the same as 5 times 5. 5 is a prime number. Only 1 times 5 equals 5. It's 2 factors. 5 is a prime number. So my prime factorization says 2 times 5 times 5. But remember, we can simplify this a little bit and we can say 2 times 5 to the second power. Remember, using exponents tells us how many times are we using that number as a factor. So maybe you're thinking, but there's other ways to break down 52. Let's try one of them. Another way that we could break down 50 would be 5 times 10. So let's see what this looks like. 5 is prime, but we can break down 10. 10 is the same as 2 times 5. 2 is prime, 5 is prime. Again, we've got 2 times 5 times 5, which is equivalent to 2 times 5 squared. All right, one more example, last example, and then I'll leave you to go do some work with this skill. 36, how could we break down 36? We could do 9 times 4, we could do 6 times 6. Either way is going to get us the same answer. Let's do 4 times 9. We can break 4 down. 4 is the same as 2 times 2. 2 is prime, 2 is prime. We can break 9 down. 9 is the same as 3 times 3. 3 is prime, and 3 is prime. So we continue breaking down until we get to all prime numbers. And this is kind of like a code for 36, right? So 36 is equal to 2 times 2 times 3 times 3, and we can say this a little bit simpler. We can say 2 to the second power times 3 to the second power, which means we multiplied 2 by itself 2 times, and we multiplied 3 by itself 2 times. All right, please let me know if you have questions. I will attach some other resources in case you need more help with this topic.